Presented by Caltech.
Hi, I'd like to introduce myself. My name is Daniel Martin, and this is Olivia Wilkins. And together we're the co-directors of the Caltech Project for Effective Teaching, otherwise known as CPET. And we'd like to welcome you today to the CPET annual seminar given by the Richard Feynman Prize for Excellence in Teaching winner. So as a student-led group, CPET is proud to promote effective teaching practices through our certificate programs and through events such as this one. So if you're interested in learning more about CPET, you can come talk to Olivia or I after this talk, and you could also email us at cpet@caltech.edu. So with that being said, we are proud and pleased to congratulate Professor Harry Gray on being awarded the 2018 Richard P. Feynman Prize for Excellence in Teaching. So please, if you could join us.
Thank you. Oh. Okay, this is when I come up, huh?
Yes. So now I'm going to introduce you.
This is where I should stand, right?
Yeah, for now.
Because of the camera. Well, there's a nice crowd here. It's pretty good.
Okay, so I'm going to introduce the prize and also Professor Gray. So the Feynman Prize was established in 1993 to honor the professor who demonstrates unusual ability, creativity, and innovation in teaching. Professor Gray joined the chemistry faculty at Caltech in 1966, where he has been a pioneer in inorganic chemistry. Before coming to Caltech, he earned his doctorate at Northwestern University, after which he spent time at the University of Copenhagen and Columbia University. In addition to his scientific prowess, Professor Gray is recognized as an educator who is dedicated to student success, thoughtful in his instruction, and perhaps above all, enthusiastic.
I am enthusiastic.
His taught courses have included advanced inorganic chemistry and bioinorganic chemistry, and he has also served as a faculty mentor for a Chem 101 chemistry tutorial taught by graduate students. Please join us in welcoming Professor Gray as he shares his insights on the joys of teaching and research.
Thank you. I've got the mic on, yeah. Thank you, Olivia. Well, what a crowd. I don't know whether to thank the organizers for putting out this big crowd or getting mad at them for expecting so few. Anyway, it's wonderful to share some of my experiences. You left out the fact that when I came here, I taught Chem 1 for many years. That's been so long, and I'll talk about that in this little lecture. I won't show any slides, no PowerPoint, because I've always believed that the best teaching is done on the chalkboard, and that's what I've done all my life. I may have slipped one or two times, but not very much. I find that if you do PowerPoint, you get too far ahead, go too fast, and Ruben, and so I usually like to do a chalkboard. But I'd like to start by telling you how I got started teaching. I got started in a way that's very different from what you do now, Greg. And now, as you know, Greg, if you want an academic job in chem, you have to apply for it. And you have to have proposals for research, and you have to have proposals for teaching. And you have to go through interviews and spend all of your time trying to convince people how great you are. You have to go do proposal talks and on-site interviews. And you have to negotiate packages, startup packages, for more and more money. Well, I didn't do any of that. When I started, I was a postdoc in Copenhagen, minding my own business, actually doing ligand field theory. And one day in July, 1961, you can figure out I'm pretty damn old from that. Let me repeat. In July 1961, figuring out how to work a ligand field theory problem, or working on some new stuff, a letter arrived, a little letter, tattered little letter in ordinary mail. It might have been air mail from Columbia University in New York, from the chairman of the department, whose name was Charlie Beckman. My life has been full of Beckmans, but Charlie Beckman was the first Beckman. And I opened the letter, and there was an offer of a job. I hadn't applied for the job. I only knew one professor at Columbia, and I didn't know him very well. That was Martin Karpeles, who apparently knew a little bit about my work in ligand field theory. I suppose enough to tell the department at Columbia that they should make me an offer. And they did. So I didn't have a CV, Jack. I didn't have any proposals. I didn't have a teaching plan. I didn't have anything, but I did have a job. And so I accepted it. And 2 months later, in September of 1961, I showed up at Columbia, burst into the chairman's office, Charlie Beckman, and full of confidence. And I burst in, and before I could say anything, he looked at me and he said, "Who the hell are you?" And I said, "I'm Harry Gray. You made me an offer of a job." He said, "Oh, yes, that's right, I did. And I'm glad you're here because we have a course for you to teach starting tomorrow." And I said, "Okay." And that's how I got started in teaching. That was my start. He had a book that he said, and he explained what the course was. It was a course called Chemistry 910. You may remember or not that at that time Columbia College was all men. And you could only take courses at Columbia College if you were a man, Kim. You couldn't take a course at Columbia. Even if you were at Barnard, which was across the street, you could not take a Columbia College course. This I thought was really ridiculous. And later I fought that. But at this time, Charlie Beckman explained to me, the reason we're giving you this course, Harry, is because we're phasing it out. This is the last time it's going to be taught. And so you can't do any harm in this course. And here's the book. And he handed me a book. It was a sort of thermodynamics book. And I knew I didn't want to teach that. But then he explained, he said, this is an honors freshman course, and we frankly don't have enough faculty here to keep this course going. So we're going to phase it out and just teach one big freshman course from here on. And so he says, you can teach whatever you want. I said, good. So I threw away the thermodynamics book, and I met the class the next day in 316 Havemeyer Hall, had 77 seats in that room, which is no longer there. But there were 77 young men there waiting for me, Columbia College kids. And I started much like I'm starting with you now, saying, I went in and I said, well, I'm Harry Gray. I'm not a lot older. I was 25 years old. I'm not that much older than you are, so we're going to bond. And I just came from Copenhagen, and I got this job by accident. And so we're going to phase out this course. Let's do something interesting. I said, I've been working on ligand field theory in Copenhagen, and I've got some ideas about how to teach bonding that I'd like to try on you guys as sort of an experiment. Because, in courses at that time, bonding was taught with Lewis structures, Dan, and Linus Pauling's valence bond theory, which I didn't like because it didn't explain any colors of the compounds I was interested in. but my ligand field theory that I'd been developing in Copenhagen did. I had letters from Linus Pauling, actually, Linus had written me and knew about this, and he wrote to me and said, "Harry, you're wasting your time on this ridiculous theory that you're working on. I can explain it better with valence bond." And I wrote him back, says, "No, you can't." So I got the class going, and they were a very enthusiastic bunch of kids, and they bought into this with me. And so that's when I started developing a way to teach molecular orbital theory for the first time to freshmen. And I did, and it was an incredible experience. And I fell in love with teaching. I fell in love with teaching because I realized that I could somehow incorporate stuff I was doing in research into my teaching, not at the level I was doing in research, but things that were related to directly to my research. I could go and develop MO theory for freshmen at a level which I felt they could understand and work with me. So that's how I got started in teaching, was to take the research I was doing and teach it in a certain way that they could appreciate. And they loved it. They loved it, and I got great ratings. And I bonded with all these kids. I still, by the way, they all became doctors, or almost all became doctors, which the Columbia kids always did. But real doctors, not fake doctors. Not a doctor like you, Greg. A real doctor. And I still exchange emails with them, many of them. 58 years later. Some of them are still alive. A few of them are still alive, and I'm still alive, and they keep wondering why I'm still alive. But I am. That was my first, that's the joy of teaching, my first joy. And I fell in love with teaching, and I fell in love with the idea that you can always incorporate ideas from your research into your teaching and make it come alive for people, and the students love that more than just some boring recitation or reading out of the book or something. Well, based on that course, I wrote a book, my first book. I wrote it immediately, Electrons and Chemical Bonding. It was published. I was going to bring it down here, but I forgot. I'm a little dizzy, Dan. Anyway, I wrote this little book, Electrons and Chemical Bonding, based on the course. A couple of kids in the course had taken very good notes. They gave me their notes, and then I wrote the book, Jack. And you know that book because you told me that I was the first guy to explain the photoionization from water, from different levels in water. Jack told me that later. I've never forgotten that because you can't teach Jack anything, but I taught him that one thing of how to think about water. And then I wrote the book, and I was so proud of the book. It was my first book. It was published in 1964, 2 years after I taught the course. And I thought the book was perfect. I thought I had made no mistakes in the book. The book was absolutely perfect. And so later, when I went into a larger class, which I'll tell you about in a minute, the book had just come out. I took it into the class, and I looked at my class. Now I had 400 kids now. I said, "I've just written the perfect book, and here it is. I'm so confident it's the perfect book that I'll give anybody here 50 cents for every error you find, because I'm confident there's no errors in this book." 2 weeks later, I had shelled out $400. But Kim, it was worth it because the book had then sold the first printing, and I could then take all of those corrections and do the next printing. And now the book is perfect. Nobody since that time has found another error. Now, I talk about this because this book has had a lifetime of its own. The current version of it, called Chemical Bonds, is used now. Nate Lewis has been using it for years and still using it in Chem 1. So that book I wrote based on my first course at Columbia on how to do MO theory for freshmen is now chemical bonds and still used here and many other places. So it's had a very long life. Well, I got really good ratings that year, and the Columbia faculty members, I got to know the faculty during this time. I hadn't known any of them before. And they thought I was a little arrogant and a little cocky, and because I was bragging about how great my kids were in my course and how much I was lighting them up with my super teaching and stuff. And so Ron, I'll never forget, Ron Breslow said at the end of the year, he said, "Harry, if you think you're so good, why don't you try to teach the big freshman course, the 400 student course?" And I said, "No problem. I'll be happy. I'd love to do that." And so the second year, after we phased out 9-10, that course was gone, I threw in with the big course at Columbia, the big freshman course. It's taught in this wonderful arena 309 Havemeyer, where many movies have been made and many TV programs. It's a wonderful arena for teaching, 309 Havemeyer. If you've ever at Columbia, you should go visit that. Jay, have you been in 309 Havemeyer? Well, it's the one place you haven't been. I suggest you go. Any rate, it's a wonderful place with a huge lecture demonstration place, and behind it is a big place to make up solutions. And Breslow said, "Harry, if you think you're so good, let's see if you can keep people coming to this course." There are 400 kids, and every year after the first 2 lectures, the crowd drops to about 50. I said, "Ron, I can keep them all there. Just you wait." And I found an old Frenchman by the name of Fouget, Michel Fouget, who had been at Columbia for years and had been largely ignored. In the 30s and 40s, he was a lecture demonstrator, but that had gone out of fashion, and he was now relegated to make up solutions for various labs. He wasn't really part of the thing, and I found him. He had a wonderful collection of lecture demonstrations. And I coupled with him, and I said, "Mr. Fouget," and I called him Mr. Fouget, and he had a wonderful French accent. He called me Professor. And I said, "Mr. Fouget, we're going to keep these kids coming to Chem 1. It had another number there, but it's like our Chem 1. We're going to keep them there, and here's what we're going to do, Mr. Fouget. You and I are a team. You've got all these wonderful lecture demonstrations, and I can do a lot of talking. And so we're going to do a dialogue every Monday at class. We're going to have a little dialogue with me, with my whatever, and your French accent. We're going to get these kids hooked, and we're going to have a little dialogue every the first lecture in the week, and we're going to tell them what we're going to do as a lecture demonstration the next time. We're going to hook them so they come the next time, and we're going to have this little dialogue." And Mr. Fouget had some incredible demonstrations. He had a rocket ship, a bell jar full of hydrogen that you took off like a rocket. By the way, all his demonstrations were extremely dangerous. And he would say, "Professor, are you sure you want to do this?" And I said, "Yes, I want to do this." And so we would have a little dialogue at first in the class, and we would hook them, tell them, "You know, if you come next time, we're going to do all these life-threatening demos. You're going to have a blast. You're going to see if we can survive these demos." And we had a whole bunch of great demos. So Fouget and I held forth in this course for 4 years in a row, and it was standing room only. Every lecture, people would come in from other places to see this dialogue that we did, and these demos we did. And in fact, the New York Times found out about this, and they sent their science editor, Walter Sullivan, to come up. He didn't believe we did this stuff. That was the day when we did the enormous crystallization from a supersaturated sodium acetate solution, which we did every year. And we would start with a dialogue, and I would say, Mr. Fouget, are you ready to do the sodium acetate demonstration? Professor, I am ready. and then I would explain that Mr. Fouget kept adding sodium acetate day after day after day carefully, can't get any dust in it, and I had a huge beaker. We scaled up everything. And I had a beaker that Mr. Fouget could barely get his arms around. And we would talk to the class, and I'd say, now here's the way it's going to go. It's going to take Mr. Fouget 2 weeks to make this up, because he has to add sodium acetate slowly every day and nurse this thing until it's super, super saturated. And then he's going to bring it in to me and the podium, and I'm going to have the seed crystal in my hand, and I'm going to drop it, and it's going to crystallize. And by then in the class, and I said, you can't make a sound when he comes in, because if you do, he'll shake and it'll crystallize right in his arms, and it's extremely exothermic. And this will fry Mr. Fouget. I didn't say French fries, but I could have. In 4 years of this experiment, Fouget never made it to the podium. and if you want to check this out, go look at the old New York Times, because Walter Sullivan didn't believe this, and he sat where Zev Gross is sitting in the front row. And Mr. Fouget got about to Walter Sullivan when somebody says, whistled, Fouget jiggled, and it crystallized, and he says, ah! And the sodium acetate was all over the New York Times guy. It was written up the next day. There's a nice article in the New York Times about this crazy pair of idiots at Columbia who do these crazy demos. Well, that's the joy of teaching, is getting the kids there. Because if they don't come, you can't teach. So when I got to Caltech, I have to say one other thing about my time at Columbia. We had cheating at Columbia. We had TAs all over the place proctoring exams. That was the sad part. That if you didn't, up the aisles and so forth in exams, if you didn't look at all the papers all the time, you could be sure there would be cheating. I had never heard of the honor system until I was invited to Caltech to give a course here in the spring of 1965. Jack Roberts wrote me a note saying they'd like me to come out and teach they never had Jay Labinger knows this. They hadn't had inorganic chemistry taught here. They had it on the books, but it hadn't been taught because the fellow who was supposed to teach it had gone off the deep end and was teaching Boolean algebra instead of inorganic chemistry. So if you want to learn about this, read Jay Labinger's book. I encourage you to buy it. It's a very nice book. I thought I'd give you that shout out, Jay. I know you need the money. Anyway, I came out and to teach the course. I'd never been to California. I came out and loved the campus. It was really nice. The first time I'd ever seen it, this was the spring of 1965, and they said, you can teach the inorganic chemistry here to our kids. And by the way, we're on the honor system here. We have a very tight honor system. You should give exams that kids can take home over the weekend to work out. I said, you mean there's no proctors? There's no cheating? He said, yeah, there's no cheating, there's no proctors. You can trust all the kids here. We're on the honor system. I said, well, I don't believe that. I'm from Columbia, give me a break. And so I gave a lecture. I started lecturing. I gave my first exam. I had a very tough derivation on this exam. It was a 3-hour exam, and I gave it with some trepidation. I gave it to let the kids take it home over the weekend. And I said, well, I'm a little nervous about this. They handed the exam in. The smartest guy in the class, maybe not as smart as you, Lucio, or maybe not Dan, but pretty damn smart, had started the derivation, and he clearly knew exactly how to do the derivation. He'd gone on this and this and this and this, and right before the final, conclusion to the derivation, just slightly before, he stops suddenly on this paper and wrote, "My time is up." It was a 3-hour timed exam, and I said, "Whoa." Boy, this honor system, this is really cool. I would love to be at this place. And I tell you, the honor system here is so special. It really is. It's so different and so special from other places where you have to, think that you have to monitor things all the time and worry about that. This is so cool. Well, when I came out here in '66, they made me an offer. I came out in July of 1966, as was mentioned. And Chem 1 here, I'd been teaching these big classes in freshman chemistry, and I loved that. I loved our big audiences, and I loved to talk, as you know, and I loved all of this kind of stuff. But here, Chem 1 was taught by a specialist, Jörg Vaser, who had the course and did a great job. He was a great guy, and he gave a great course. And I couldn't horn in on this. So as Jack Bishop knows, I coupled up with a guy named George Hammond. George Hammond was an organic chemist here, and he had the vision, the idea that the chemistry curriculum was 30, 40 years out of date. It was organic, physical, analytical. And he said, we've been teaching these boring courses for years, and we've got to have a new curriculum. And the Hammond curriculum, which he had proposed, that we dump the old chemistry curriculum, the Hammond curriculum was, everything was integrated into structure, dynamics, and synthesis. 3 areas. All the organic and inorganic would be put into structure, dynamics, and synthesis. And he recruited me because I was looking for something to do, because Jörg Vaser was teaching Chem 1, and they let me teach inorganic, but I needed something else to do, so I threw in, as Jack knows, with George Hammond. And we invented a course called Chem 2, which was the introductory course. Chem 41 then, we dumped organic chemistry, Greg, and I taught Chem 41 with Hammond and a guy and a TA named Carl Wamser. We taught 41 as a structural chemistry course for a year. Now, Jack Roberts hated this. In fact, all the organic chemists in the world hated this, and they hated us because we were going to dump organic chemistry and replace it with a course in structural chemistry. And Roberts was the chairman of the division, so he said to us, he says, Harry and George, says, it's okay for you guys to try this out, but you're going to teach your regular courses as well. You have to add this to what you're regularly doing. We said, okay. And so the organic course went on, but George and Wamser and I taught 41 for a year, structural course. And I have to tell you, I was miserable. The first time I was miserable teaching a course because there were no reactions. How many times can you describe a structure? The bond length is 0.05 more than this one. I mean, for a whole year I had to talk about structure without any reactions, and quite frankly, the Hammond curriculum bombed. It was taught in a few places around the country. Stony Brook adopted it for a while, but it didn't last very long here. And Hammond and I didn't realize what the real problem was. The problem was that the chemistry courses were technically superb, and they still are. The organic chemistry course is a fantastic course, and it always has been. Technically superb teaching. But what the kids need to know when they come into introductory chemistry and organic is They need to know what's exciting about chemistry, and they can only do that if they start research. They start research early. And Hammond and I didn't figure that out. We thought it was a curriculum problem. We were wrong. The idea was, when the kids come in, you've got to hook them and get them in research labs so they have a need to know. Once they start playing around with chemicals, they have a need to know. They have a need to take the organic course. They know why they're inorganic. They know why they're studying thermodynamics, because they're wrestling with problems in research. And that was invented many years later, I'd say, by Jackie Barton and Nate Lewis, who figured that out, and we started Chem 10 many years later, and it's been a huge success. Now we have all these kids like these two in the front row who've done tons of research and published papers and are very happy. You're happy, aren't you, Dan? Tell me you're happy.
I'm happy here.
All right. Good. Well, then Vaser retired, and I got to teach Chem 1. In Chem 1, I had to have the Fouget Act because I knew I'd had to keep, because it was a required course, and engineers didn't want to take it, and physicists didn't want to take it. Nobody wanted to take it. So I had to do my act again, and Mr. Fouget here was my first graduate student by the name of George Rossman, who, by the way, won the Feynman Prize many years ago. I'm following in his footsteps. He was my first graduate student. George had all kinds of great ideas about reactions we could run, particularly clock reactions, particularly double clock reactions, where two colors, you get one color after a few seconds, you get a second one, and George knew the whole thing. And we invented and we packed the house in 22 gates because we did the same thing. George and I have a dialogue about things. And I made a pact with the class. I said, we'll entertain you on Monday if you promise to come on Thursday, where we'll do some teaching. If you'll all come, we'll just entertain you with life-threatening demonstrations first, and then you'll have to promise to come so we can teach you one day. And that's all you need is one day a week. And that worked, and we packed the house. If you go back and see, you had to get a seat. Believe it or not, you had to get a seat in 22 gates at 10:30 before 11 o'clock showtime. In fact, the California Tech always had a front page thing. It's showtime in 22 gates. George and I had a big act. We did a lot of, George and I developed this double chemiluminescent clock reaction, which is a spectacular luminescent clock reaction, which you mix a bunch of things, and after 7 seconds you get a big flash of light and it goes dark. After 15 seconds you get a second huge flash of light and a fountain of light. And when we scaled it up to show the alumni in 147 gates, you don't want to scale things up. When we scaled it up, we had a huge Erlenmeyer and we were mixing stuff, and when we had that second shot of light after 15 seconds, that fountain of light hit the ceiling on 147. There's been a big black spot up there for years. And the Erlenmeyer blew up in George's hand. Blew out the bottom. It's very exothermic, and the stuff coming out is very toxic, so it's a really cool demo. And George looked at me after, it's like one of those cartoons where the thing's blowing out the bottom. He's holding the neck of the Erlenmeyer, and the rest of it was gone. He looked at me and says, Harry, I don't think we're going to run this again. And we haven't. That's the last time it was run. But with all of these antics, the kids got into it with me, and they started doing pranks on me. So I was the butt of all the Caltech pranks for many years, as Jack knows. I won't tell you all of them, but the one that I really liked was the one where the kids came in, the 22 gates, overnight, and they unbolted all the seats, and they turned them around and rebolted them, so when I came in, their backs to me. They're all looking the other way, and this didn't stop me. I grabbed a portable blackboard, went up to the clock at the top, and I did the lecture at the top looking down at them. But George and I dressed up. We decided we had costumes. I dressed up as a horse. I wanted to get the gorilla costume, but I couldn't get the head on. So I had a horse outfit. We had a leopard outfit. I had a Richard Nixon outfit. I had a King Faisal outfit. Sorry, Jeff. And we dressed up, and we gave talks in costumes, and to keep all the kids excited about stuff. And then I got the name Harry the Horse. People started calling me, as you know, Jack Harry the Horse. And so when they cast Guys and Dolls, the big musical here, the kid said, Harry, you're Harry the Horse. You got to try out for Harry the Horse. He's a big gambler in Guys and Dolls. It's a big part. So I tried out. I got the part. And that's relative to the Feynman Prize. That's when I met Dick Feynman. Because Dick Feynman did the bongo drums at intermission in all the shows. And so I got to know Dick really well by rehearsing every night in Guys and Dolls as Harry the Horse. And we did 3 shows together. Dick Feynman and I did 3 shows together. We rehearsed every night. We talked every night. He never asked me anything about what I did in chemistry, which would depress me. He asked me about all kinds of other stuff, and we bonded, and he was a great guy. And I asked him, he was a great teacher. Having the Feynman Prize is wonderful because Dick Feynman was the greatest teacher that you could ever want. He could teach to anybody. I asked him to, if he would give a lecture to 3,000 9-year-olds. The AAAS had a meeting here in Southern California, and the organizers came to me and they said, could you get somebody who could give a talk to 3,000 9-year-olds? We're going to bus them in down by USC, down by the Science Center. And I said, yeah, I'll ask Dick Feynman. He can talk to 9-year-olds. And I said, Dick, do me a favor. Would you come down with me to this thing and give a little talk to 3,000 9-year-olds? And he said, sure, I'd be happy to. I'd love to. And so I drove him down. There was this grassy knoll down there, which, answer your phone, Dan. And they bust in. There were literally 3,000 9-year-olds, and I said, I wonder how long Dick Feynman can keep these kids still before they start running all over the place. You'll never believe this, but he started talking about the stars and blah and everything, and these kids were absolutely mesmerized. He talked for 30 minutes, and they didn't move. They just looked at him. That's great teaching. You can't beat that. So getting the Feynman Prize is about as good as you can do. Anyway, I'm going to wrap up now, looking at the time. I want to leave a little time for Q&A. The message is I've always felt that research and teaching couldn't be separated. I've always hated people or disliked people who felt their role in life, their goal in life was to get a job where they didn't have to teach. They'd be professors, but they could just do research. They wouldn't have to teach. I feel sorry for those people because they're missing out. They're missing out the idea that quite frankly, if you start teaching a course, this is the first time you'll really learn the course. When you're faced with teaching a course, believe me, the fear of God is in you, that people are going to ask you all kinds of questions. So you better know the material at about 5 different levels, at a very sophisticated level, all the way down to a level that you could explain to a 2-year-old. And that's what I found. And I found that getting there and trying to understand it at 5 levels so I could answer questions from students, whatever they were, really empowered me to think about my research more than I could otherwise. A lot of my good ideas in research have come when I was struggling with teaching and trying to figure out exactly how to teach a certain subject. And then all of a sudden the light goes on. I say, well, gee, I just thought of a new experiment. So my advice to all of you is don't try to separate teaching and research. They're not separable. They're part of a whole story that will make you better. And let me tell you, if you get a student that's struggling with an issue, with a problem, with a question, and you keep working on them and give them an explanation at a level and another level, and finally you see in their face they light up because they've just figured out and understood what it was. That's the joy of teaching. It doesn't get any better than that when you light up a student and figure that you've actually made a difference in them understanding something. So I'm going to close by thanking the people I've worked with over these years, starting with Mr. Fouget at Columbia, George Rossman at Caltech, John Burkaw, Jay Labinger, Jay Winkler, Bruce Brunswig, Jonas Peters. We've all team taught things together. Nate Lewis, and my TAs. And all of my TAs over the years, I've worked with the TAs very closely. They have made my teaching much better. I couldn't do without TAs. I have a wonderful one representing them all now sitting there, Brendan McNicholas, who's working with him has been a joy. And that's true of all the TAs I've worked with, Brendan, all through the years. Thank you very much. Thank you.
Okay, we'll now open up for questions. So if you have a question, if you could please wait for one of us to bring you the mic to ask your question, and then Professor Gray will answer, hopefully.
There we go.
Do you still have your costumes, your horse costume?
Yes, I do. George used to wear the leopard costume. I wore all the others, but I'm sure I have them.
Don't break them out anymore.
And I might make another appearance as Harry the Horse. I thought about doing that at this time, but I'm not sure I can get it on anymore. Anything else?
So, that's one thing.
All right, great talk, Harry. Thank you so much. I'm curious, did you ever find it a struggle to balance research and teaching, or was it in your case you just loved both so much that the balance just came naturally on its own?
Well, I love them both, and I have found that when I'm teaching, and either one, that you really have to concentrate on one or the other. I like to have, in research, for example, in order to attack a problem, you really need a lot of quiet time over an extended period to really work on a problem. You can't, for example, do research in the morning and teaching in the afternoon or something and think about it. I think you have to have concentrated time in research to solve a problem over a period of really several days or weeks in order to work on it. The same is true in teaching. When I'm teaching, I think a lot about teaching and what I'm doing, and in that sense, I don't mix those up. Yeah, up in the back. Get a mic there.
Hello. I work with some high school kids who are not very scientifically inclined or interested, and some of them
Send
don't
them to
even
me.
So that's what I was going to ask you. So if they're not willing to make it all the way up here to Caltech, how would you motivate them to think that science is cool? I could keep telling them how cool I think chemistry is, but they don't.
Siddharth Dasgupta and I and others in our group started a solar army with the idea that the courses in high school don't really motivate kids that much, but research does. And so you can, if you've got the right mentors from graduate students or undergrads or postdocs at a university, you can You can send them into high schools to talk to kids about opportunities and career paths, but you can also get them involved in some research. It happened in our case to be materials research for solar materials, and we developed a whole way of doing this to motivate the kids and so forth. But the ones I think that we dealt with were already motivated probably, so your problem is more extreme than that in the sense that you look at kids who are just not motivated at all, and that's a big challenge. But you can start with things like getting in hands-on stuff so they can, I think that's the key, is to get them involved in doing something with their hands.
Okay. Thank you.
Hi. Like when you teach courses, of course there are students who are always on the top and some students who don't do quite well consistently, like in undergrad courses. Like how do you help to motivate them or pass the course?
How do I motivate kids who don't want to be motivated?
Yeah.
I usually tell them to change fields. I have a weekend rule. And my weekend rule applies to this. If on Friday afternoon, Dan, if you decide that you're fed up with what you're doing and you want to take the weekend off and do something different, and you do that for 3 or 4 weeks in a row, you failed my weekend rule. On the other hand, if Friday comes and you can't wait for Saturday, because then you can devote all of your time to doing what you're really interested in, which you have been doing, then you're working on something you really want to do. And if you don't want to do that after my advice is to all of you is to change what you're doing. You're not in the right field. You're not in the right thing. If you don't want to, if time comes when after the pressures of meetings and all stuff all week, and you have a Saturday or something that you could devote entirely to working on stuff you want to work on, then you're in a field that's probably right for you. And if you can't wait on Friday to get rid of what you've been doing, then you should change fields. That's my advice.
Hi, Harry.
Oh, hi.
Hi.
Alex, how are you?
Doing pretty well.
How's your research going now?
Going great, thanks.
How's your teaching?
No teaching yet.
Okay.
Okay, so I have kind of more of a philosophical question when it comes to like structuring teaching at research institutions. It seems like a lot of research institutions now are creating these like bifurcated roles where you have research faculty and then distinct like non-tenure track full-time teaching staff.
Yeah, I'm really opposed to that. I can't stand that.
Yeah, and that was kind of my question. Is like, which of these two structures?
Don't continue with this question. I actually hate that.
Okay. Oh yeah.
All right, that's the answer.
Okay.
I'm for doing away with all that.
Yeah.
That's a good note for me to thank you. Oh, wait, we have another question.
Hi, Harry.
Hi.
I was wondering how the students that you've taught have changed over the years. Like, have you felt there have been generational changes, or have students been consistent over time?
I've had wonderful students for 58 years now. I love them all. I've kept in touch with all of them who are still alive. And I found differences in attitudes as the years go along. For example, in the 60s, kids were, really upset because of the Vietnam War and all kinds of stuff there. And then a little later, they got much more serious about what they were doing, worrying about jobs. And it goes back and forth of people being very serious, worrying about their futures and jobs, and sometimes kids just wanting to do something they really want to do and not worrying about jobs. I found all of these changes in attitudes of students over the years, but the consistent part is they've all been great. They've been great students who've done great things. And I have a record I'm very proud of. 125 professors around the world now worked with me as students. And I think that's the record. 6 university presidents, I'm not proud of that. But the professors, that's pretty cool. That's what I love. Well, that's a good place. We got another question?
That's it. So if
That's
there's no other questions, then let's please give Professor Gray.
Thank you.